Okay, this is number 74, problem number 74, and it looks like this. 74, and we're supposed to do this, root 3 minus I to the power minus 13. Okay, so basically our z is root 3 minus I, and we are asked to find z to the minus 13. Okay, let's find out where this thing is in the complex plane. So root 3 is, let's say, right here. Minus 1 is, say, right there. So in the complex plane, this is where my z is. So modulus, or r, is simply, if you look at the square root of root 3 squared plus 1 squared, and this is going to be a 2. So basically that distance is 2. Now if you look at the angle, that angle, I can go like that, I can go like this, so it's going to be negative, okay? So tan inverse of you can do minus 1 divided by root 3, and your calculator will spit this out to be pi over 6. Okay, but negative pi over 6. Now I could have ignored the negative sign in this fraction, but then after I get my calculator, I put a minus sign there, because look at the way this angle is definitely 30 degrees. We know that. However, because I'm using as the argument in the clockwise direction, it's going to be minus pi over 6. So what do we have? We have z to the minus 13. Okay, so that means r to the minus 13. Okay, and then cosine of minus 13 times your minus pi over 6, and then plus I sine of minus 13. Remember, it's n times theta, okay? N is minus 13, fine. And theta is minus pi over 6 times minus pi over 6. So this is this is 2 to the power minus 13 cosine. Okay, so that's going to be cosine of 13 pi over 6, and then plus I sine of 13 pi over 6. Now this is sine, okay? This is perfectly okay, but probably the answer in the book is not going to be like that. So 2 to the minus 13, of course, it's 2 to the minus 13. This thing in the book, probably they think about it as 2 plus pi over 6. Okay? That means that this is going to be cosine of pi over 6. And this is going to be I sine of pi over 6 also. You think about this thing as 2 pi plus pi over 6. And sine of 2 pi plus pi over 6 is the same as sine of pi over 6. So this is going to be 1 over 2 to the 13. That is root 3 over 2. And this is 1/2. Probably the answer in the book is going to look something like what you see here. Okay? Good. So let's move on to the next problem. Although the next problem, the wording looks different, in fact, it's the same type of problem. Okay, so it says, look, find the square root of 4 root 3 plus 4i. So square root, that's what it is, of 4 root 3 plus 4i. Remember, we talked about these things in class, and I told you that if you take the square root of a negative number, you get a single value. But if you take the square root or root of a complex number, you don't get a single number. You get actually, for example, if you take square root, you get 2 complex numbers. two numbers, two complex numbers. If you take the fourth root of a complex number, you get four answers. Okay, they're all okay, but just be aware of this fact. We discussed it in class. Now, first thing to do problems like that is you write this thing in the polar form. Okay, so I want to write this thing in the polar form. It is right now like so. And it's, let me see now, where am I in complex plane? So it's somewhere here. So it's going to be something like this. So this is 4 root 3, and this is 4. And I will leave it to you to find out this distance. This distance is square root of 4 root 3 squared plus 4 squared. And this is, let me see now, this is going to be, the 4 comes out, root 3 squared plus 1. So that is going to be 2. So this is going to be 8. This is going to be 8. Okay? This angle is tan inverse of opposite, which is 4, over adjacent, which is 4 root 3. And the calculator will tell you exactly what this thing is. It's pi over 6. Okay? So, what we did, we found our complex number is like this. 8, okay, cosine of pi over 6 plus I sine of pi over 6. Now, if you look in your note or the book, R is 8, theta is pi over 6. It tells you that you have two roots. Please check your notes. Let me write that. It actually in the book or in the notes in class, I wrote it like that. So there is two roots denoted by W. So R to the 1 over n. And in my case, I'm doing square root, so it's going to be R to the 1/2 cosine of theta plus 2k pi over 2, because I'm taking square root, plus I sine of theta plus 2k pi over 2, where k is 0 and k is 1. 0 and 1. Okay? So the first root of this complex number is R to the 1/2, which is 8 to the 1/2, cosine of, if k is 0, what do you get? Pi over 6 plus 0 over 2 plus I sine of pi over 6 plus 0 over 2. So this one is going to be 8 to the 1/2, which is root of 8, by the way. Now this is going to be cosine of pi over 12 plus I sine of pi over 12. This is the first root. Let's do the second root, and I'm going to use a different color for it. Oops, where is it? Okay, W1, this is for k equal to 1, this is for k equal to 0, is going to be 8 to the 1/2 cosine of pi over 6 plus 2 pi. In here, you put k equal to 1 divided by 2 plus I sine of pi over 6 plus 2 pi divided by 2. So this is 8 to the 1/2. And this guy is cosine of 13 pi over 12 plus I sine of 13 pi over 12. These are the two roots. Okay, let's do the next problem. The next problem is number 82. And your complex number is given as 4 root 3 plus 4i, and you're asked to find the third root, cube root, okay? which means z to the 1/3. Remember, cube root means there's going to be three answers you're going to have to find. You're going to have to find W0, W1, and W2. Okay? But the first thing is you have to write the polar form of that. It's helpful if you write it first in the discussion in the complex plane. It's going to look like this. So there's your 4. There is 4 root 3. This is the height 4. This is 4 root 3. This angle definitely is going to be pi over 6, just like before. Theta is tan inverse of 4 over 4 root 3, opposite over adjacent, and that's going to give you pi over 6 from the calculator or from your memorization. And that length, this length here, this length, r is equal to, well, it's the same number as before, so we already worked it out actually. This thing came out to be 8, right? Because this is the same number that we had for problem number 81. So the polar form is exactly the same. Okay, so we have to write, the formulas are going to be like that. Wk equal to r to the k, r to the 1 over k. Let me move it down here so that you don't make a mistake. 1 to the k, 1 to the n, not k, 1 to the n, okay, times cosine of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. Remember, n is 3 here, so that's going to be 8 to the power 1/3. Cosine, and we already did this, it was pi over 6 plus 2 pi k over 3 plus I sine of pi over 6 plus 2 pi k over 3. Okay, so k equal to 0. The first root is going to be 8 to the 1/3. By the way, 8 to the 1/3 is 2. I understand that. Let me move this thing. Let me move this thing up a little bit. Okay, and when k is 0, it's going to be cosine of pi over 18 plus I sine of pi over 18. When k is 1, W1 is going to be 8 to the 1/3, which again, incidentally, is 2. Cosine, okay, in here, you put k equal to 1. What do you get? You get 2 pi there. Pi over 6 plus 2 pi is 13 pi over 18 plus I sine of 13 pi over 18. And then k equal to 2. W2, the third root is 8 to the 1/3. Cosine, if you set k equal to 2 here, you're going to get 20. If k equal to 2, right? If k is equal to 2, it's going to give you 4 pi. 4 pi plus pi over 6 is going to be 25 pi over 18 plus I sine of 25 pi over 18. Bingo, that's it. You got the 3 roots. Let's do the number 83. Number 83. It goes like this. Z equal to minus 81i. Find fourth root. Z to the 1/4. And there's going to be 4 answers. Okay. So the first thing is to write the polar form of that. Let's see now. Where is this minus 81i? So it's going to be somewhere down here. This is minus 81. Okay. So your modulus is going to be 81. Is that distance? 81. Okay. And your angle, just look at it. It's going to be, the angle is going to be, for example, minus pi over 2. So Z is equal to 81 cosine of minus pi over 2 okay? And what is that? Plus I sine of minus pi over 2. Now we can play it smart here uh, and realize that this thing is 0, right? I mean, this is 0. This thing is 0. So we can play it smart and just drop this, or we can play it dumb and write it down and then keep going on. So WK is equal to R to the 1 over, we're doing the fourth root, right? So 1 over 4 cosine of minus pi over 2 plus 2 pi k divided by 4, because the fourth root, plus I sine of minus pi over 2 plus 2 pi k divided by 4. I mean, we are writing these and carrying it, but well, just leave it the way it is. Okay, so k equal to 0, we get W0 equal to 81 to the 1/4, which incidentally that's 3, but that's okay. So cosine of, when k is 0, this goes away, so we got cosine of minus pi over 8. Actually, don't drop. You cannot drop this, because notice that it actually contributes here. So I will take back what I said. Do not drop that guy, because if you drop it, then obviously it's going to disappear. This term is going to disappear. So you cannot drop this. Do not. There's nothing wrong with this. This is fine. You can drop it, but when it comes down to finding the roots, you have to carry it. Look, no problem with this. There is no problem. This is 0. I understand that. But when you try to find the roots, you need to have it included. This is why it's still there. Plus I sine of minus pi over 8. I feel bad because I said drop it. Well, drop it. There's nothing wrong with dropping it for Z, but you need it down here for the W for the roots of that thing. K equal to 1, W1, 8 to the 1 over 4, cosine of minus pi over 2 plus 2 pi divided by 4. I'll leave it like this. I'm not going to simplify it, but in the book it's not going to be left like that. Minus pi over 2 plus 2 pi over 4. K equal to 2. W2 is going to be 8 to the 1 over 4 cosine of minus pi over 2 plus 4 pi over 4 plus I sine of minus pi over 2 plus 4 pi over 4, and then k equal to 3, W3 equal to 8 to the 1 over 4 cosine of minus pi over 2 plus 6 pi over 4 plus I sine of minus pi over 2 plus 6 pi over 4. Okay, good. These are the 4 roots, and we got them. Now, as for problems 91, it's the same type of problem. So it says, find all solutions to this equation. Okay, let me see now. It says solve the equation. It says solve the equation. Solve this equation. Now, it means Z4 is equal to minus 1. Another way of saying this is find 4 roots, the 4 roots or all roots of a minus 1, of Z equal to minus 1. So this is fine. There's nothing wrong with it, except that it's equivalent to saying that find 4 roots of minus 1. Okay? Now, we have done problems. Okay, so the trick was uh, write this thing in the polar form. So where is z equal to -1? So it's going to be somewhere here. Let's break is -1. So the polar form is that distance, which is 1, and there is the argument. So the modulus is 1, and angle theta is pi, right? So uh, my complex number, which is -1, can be written as 1 cosine of pi plus I sine of pi. Okay? Now we know the four roots are like that. WK is going to be R to the 1 over 4 cosine of pi plus 2k pi over 4 plus I sine of pi plus 2 pi 2k pi over 4. Okay, so there's 4 of them. K equals to 0. So W naught. R is 1, so I'm not going to even bother writing it. 1 to the 1/4. When K is 0, you're going to get cosine of pi over 4 plus I sine of pi over 4. That's the first root. When K is equal to 1, W1 is going to be 1 to the 1/4 cosine of pi plus 2 pi over 4 plus I sine of pi plus 2 pi over 4. When K is 2, W2 is equal to 1 to the 1/4 cosine of pi plus 4 pi over 4 plus I sine of pi plus 4 pi over 4, 4 pi over 4. And finally, when K is 3, the last root is 1 to the 1 over 4 cosine of pi plus 6 pi over 4 plus I sine of pi plus 6 pi over 4. I just caution you, the answer in the book may not look exactly like that because they have simplified, for example, the values of cosine of pi over 4 and sine of pi over 4 and all these things. But as far as I'm concerned, this is fine. We can leave it like this. And the last problem in this group is going to be uh, number 93, which says solve z to the 3 minus 4 root 3 minus 4i equal to 0. Now that means, let me draw it like this. This means z3 equal to 4 root 3 plus 4i. And another way of saying this, find roots of z equal to 4 root 3 plus 4i. Okay, just like the previous problem. And we have done find the three roots. How about that? The three roots. There's three of them, right? So let's find out where this thing is. 4 root 3 is going to be something like that. This is 4 root 3, and this is a 4. This angle, we have done it so many times. This is going to be pi over 6. Okay. And your R is going to be, we have done this, root 3 squared plus 4 squared. And I believe this came out to be 8. Okay. And theta came out to be pi over 6. We did this problem, okay, but I'll write it anyway. So we go, the three roots are wk equal to 8 to the 1/3, r to the 1/3, cosine of theta, which is pi over 6, plus 2k pi over 3, plus I sine of pi over 6, plus 2k pi over 3. Okay, now start k equal to 0. The first root is 8 to the 1/3 cosine of pi over 18. Remember this? We did it. I sine of pi over 18. When k is equal to 1, W1 is equal to 8 to the 1/3 cosine of pi over 6 plus 2 pi over 3. We did this. Sine of pi over 6 plus 2 pi over 3. And finally, k equal to 2. These are the three roots. W2 is 8 to the 1/3 cosine of pi over 6 plus 4 pi over 3 plus I sine of pi over 6 plus 4 pi over 3. I want to remind you that this thing that I just did was problem 82. Okay, problem 82. Okay, problem 82 worded in a different way.